Let us now look at some BJT data sheets and familiarize ourselves with the parameters of the BJT. This particular data sheet which I have flashed on the whiteboard is an NPN BJT, NPN transistor 2N222X, 222X. See, the one which I am marking here, 2N2222, is a pretty popular NPN transistor. Normally it comes in this TO18 package. This is the TO18 package, what you see here. The collector emitter, look at this one, VCEO, collector emitter voltage with base open, 30 volts. IC, the collector current, 0.8 amps rated. Maximum junction temperature 175, don't go beyond that. And this is the total power dissipation that it can handle. Cannot dissipate more than this. Thermal resistances. So junction to ambient, if you are not using any heat sink, just plain TO18 package, junction to ambient is around 300 degree Kelvin per watt. Junction to case, if you are talking only junction to case, you could use a heat sink which fits onto the TO18 case. Junction to case is 83 degree Kelvin per watt. So these are some of the electrical characteristics that you would see. The collector base breakdown voltages, collector emitter breakdown voltages. These are the important parameters 2N222, which you can look at, that we have been discussing all along, and you can the HFE parameter. Look at this. This is nothing but beta. So you will see that it is greater than 35 here, and at different current ratings. Remember that we plotted a graph. We plotted a graph of beta versus IC, and it was not a constant, right? So you have the beta at different values of IC, 0.1 milliamp, 1 milliamp, 10 milliamp, so on, 500 milliamp. So you will see different values of beta coming into the picture. So you see the variation is quite large, 3:1. So this is something that you would find the data sheet, and while designing you have to take that into account, take the worst case values for design. Dynamic characteristic, look at the bandwidth, you see greater than 250 megahertz. Switching times, delay time, rise time, storage time, fall time. These are something that we discussed in the dynamic characteristic. And for the 2222, delay time 5 nanoseconds and rise time is 15 nanoseconds. This is for turn on. Turn off, there is a storage time. You see, storage time is pretty large, 190 nanoseconds. So it takes quite an effort to remove the stored base charges. And the fall time of 23 nanoseconds. There is another very popular transistor, which is the 2N3019. That is also an NPN silicon planar transistor. It comes in the TO39 case, the most common one. And it is very popular because it is having a collector current of around 1 amp, or several applications fall in that category. And as a switch collector emitter with base open, it can withstand up to around 80 volts. Look at this base, the emitter base with collector open. When you reverse bias the base emitter diode, you should not apply more than 7 volts. So you cannot have the voltage applied across the transistor in the negative direction more than 7 volts, otherwise it will break the emitter base diode. So junction temperature of 200 degrees centigrade, and you see the R theta junction to ambient 218 and junction to case 35 degree Kelvin per watt. And you also have likewise the electrical characteristic, the static characteristic. You have the breakover voltage which is given here, greater than 80, not to go beyond 80, and do not go negative beyond 7. The saturation voltage VCE SAT that we were using for calculation of the on-state losses, 0.2 volts to 0.5 volts at different base currents and the collector currents flowing through it. VBE SAT is around 1.1 volts, and you will see again HFE varying from 50 to 100, 300. And then in the dynamic characteristic, you have the turn on. Turn on is around 100 nanoseconds. Turn on contains both the delay time and the rise time. Turn off contains both the storage time and the fall time, around 500 nanoseconds. So this is a typical, very popular. This is the NPN. You also have the complement of that in the PNP. It is called 2N4033. Let me probably show you that data sheet too. So here is this, the PNP device, which is complementary to 4033. So this is a PNP BJT 2N4033, which is complement to 2N3019. So see the VCEO, collector emitter voltage with base open is around 80 volts. 1 amp collector current. The thermal resistances around JC, R thermal junction to case, is around 80 to 40 to 80, 40 degree centigrade per watt. It is similar to the 2N3019, which is around 35 degree centigrade per watt. The electrical parameters are also given. You see the various collector base cutoff current, emitter base cutoff current, collector emitter cutoff current. This is around 25 nanoamps. This ICEX is collector to emitter current when the base is open, 25 nanoamps. So this is what we used to call ICE 0. And you have HFE here. HFE again varies and around the similar range. These are the minimum values. Minimum values vary depending upon the collector current that is being passed through the device. All this. And the maximum value is 300. VC is SAT 0.15 to 0.5. VB SAT is around 0.9 to 1.2. So you have all the characteristics. These are some of the typical values. Look at the switching characteristic, very useful for us. On time, rise time, storage time, fall time. So you have the delay time, 15 nanoseconds. Rise time, which is 25 nanoseconds. Storage time, 175 nanoseconds. Fall time, 35 nanoseconds. I will also show one more data sheet, and this is the TIP122. TIP122 is the popular Darlington pair, Darlington transistor. and 127 is its complementary pair in PNP. 122 is NPN, 127 is PNP. It comes in this TO220 package. This is a TO220 package style. The parameters are like this, the absolute ratings. VCEO is around 100 volts, and maximum collector current that it can handle is 8 amps. It can dissipate up to 65 watts, maximum junction temperature of 150 degrees centigrade. Thermal resistance junction to case 1.9 degrees centigrade per watt. See, it is less. Junction to ambient is 62.5 degrees centigrade per watt because of the package type. It's a TO220 package. ICEO, the collector cutoff current when IB is equal to 0, 0.5 milliamps. Then you have VCE SAT is around 2 to 4 volts. And HFE, see, this is important. Darlington, you need to have a very high beta. Beta is of the order of 1000. So I was mentioning, this is the main advantage of the Darlington. And TO220 mechanical data, I will leave that for you to explore.